In this video, I'm going to talk about electric fields. I'm going to place a positive charge here. It will create a field around it. If you place a positive charge here, it would experience a repulsive force, right? Because both of them are positively charged. Now, if you're placing a negative charge, let's say this point, it would experience an attractive force. A force. You can do the same thing with a negative charge as well. A negative charge would create its own field where it would attract positive charge and repel negative charge. Now, how do we measure this electric field? Let's say we want to measure the electric field at this particular point, P. To measure the electric field strength at this particular point, I'm going to place a very small test charge, a positive test charge at this point. And I'm going to measure the force exerted by our main point charge on this test charge. Let's say the force experienced by the repulsive force experienced by this positive charge is let's say random number 10 newtons, and this positive charge has a magnitude of, let's say, 0.2 coulomb. Then how do we measure the electric field at this particular point? This is the equation for electric field. Electric field is a vector quantity. E equals force on a test charge, Q dash, divided by the magnitude of that test charge, Q dash. Force is another vector quantity. So electric field at point P will be equal to force on this test charge is 10 newtons over the magnitude of the test charge is 0.2 newtons, 0.2 coulombs. So electric field will be 100 by 2, which is 50 Newton per coulomb. Newton per coulomb is the unit of electric field. E equals F by Q. Unit of E equals unit of F over unit of Q. Unit of force is newtons and unit of charge is coulomb. So the unit of electric field is Newton per coulomb. Now, if you want to measure the electric field at this particular point here, let's say Q, place another positive charge here, positive test charge here, and measure the force on this one, let's say 8 newtons, and this test charge is, I don't know, 0.1 coulomb. The magnitude of the test charge should be much smaller than the main point charge. Let's say main point charge is Q equals, I don't know, 1 coulomb. This is 0.1 coulomb. It shouldn't interfere with the field created by the main charge. That's why we are taking a very small test charge. Okay, how do we find the electric field at this particular point? Force is 8 newtons and the charge is 0.1 coulomb. So electric field at this particular point will be 8 divided by 0.1, which is 80 newtons per coulomb. Now I'm going to define another equation to find the same electric field using the main charge Q. Okay, so the same scenario, I have a main point charge Q, and at a distance R, I have a much smaller test charge Q dash. I'm going to find the force of repulsion between them using Coulomb's law. F equals K Q1 Q2 over R square. So F equals K, Q1 is the main charge Q, Q2 is the test charge Q dash, divided by the distance between them. Now to find the electric field, our equation is F over Q dash. So E equals force is K Q Q dash over R square divided by Q dash. We can cancel out Q dash. So E equals KQ over R square. That's the equation for electric field using the main point charge. In this equation, E is the electric field, K is the Coulomb's constant, 9 times 10 to the power of 9 Newton meter square per Coulomb square. Q is the point charge, the main charge. R is the distance between the point charge and the test charge, or the distance from the point charge to the point where you want to measure the electric field. Let's solve some level 1 problems. I have a positive charge Q. This is my main point charge. Let's say 2 microcoulomb. I'm going to measure the electric field at a distance 3 meters from this point charge. What is the electric field at this particular point? Our equation for electric field is E equals KQ over R square. K is Coulomb's constant, 9 times 10 to the power of 9. Q is the point charge. In this case, it is 2 microcoulombs. So 2 times 10 to the power of minus 6 over a distance to the point where you want to measure the electric field, 3 square. That is 2000 Newton per Coulomb.